Hello, geometry students. Here is your lesson for Section 2.2, Conditional Statements. Missy McCarthy, Okemos High School Math Instructor. There are several I can statements for this particular section. If nothing else, by the time you're done with this lesson, you should know what a conditional statement is, because every I can statement has conditional statement in it. I can identify, write, and analyze the truth value of conditional statements. I can find counterexamples for false conditional statements. I can identify the hypothesis and conclusion of a conditional statement. I can write the inverse, converse, and contrapositive of a conditional statement. I can write a conditional statement from a sentence or a Venn diagram, and I can use P implies Q notation for conditional statements. So we got to know what a conditional statement is. A conditional statement is a statement that can be written in the form if P, something, then Q, something else. Okay, so if there's a football game today, then I have to remember to bring my equipment. Or if it is raining, then the game is canceled. Those are examples of conditional statements. The first part of the conditional statement, the part that follows the if, is what we call our hypothesis, and that's represented by the letter P. The second part, the part that follows the then, is what we call our conclusion, and that is represented by the letter Q. So oftentimes we will write P, and this is the word implies, the symbol, P implies Q. If P happens, then Q will happen. We can also represent it with a Venn diagram, where P is a smaller subset of things, so if this happens, then Q, this larger thing, will happen. So one statement that we'll use over and over again in this class is if two angles are vertical, so this is my P, which is also known as my hypothesis, then the angles are congruent. So then this is my Q, which is my conclusion. So that's what a conditional statement is. So we're just going to quickly identify the hypothesis and the conclusion of this conditional statement. If today is Thanksgiving Day, then today is Thursday. So the part following the if is our hypothesis. This is our hypothesis, also known as P. Then today is Thursday. Today is Thursday is our conclusion, also known as Q. So the next sentence says, a number is a rational number if it is an integer. So the if gives us our hypothesis. If a number is an integer, this is actually the hypothesis of this sentence, then the number is a rational number. So this would be the conclusion of this sentence, of this conditional statement. Okay, so for these, we have to recognize that many sentences without the words if then can be written as conditionals also. So to do that, we first must identify the hypothesis and conclusion, and then use that to write our if-then statement or our conditional statement. So we're going to write a conditional statement for the following. An obtuse triangle has exactly one obtuse angle. So my if, the first thing that has to happen is the triangle has to be an obtuse triangle. So this is my P. And my Q, if that's the case, then that means that it has one obtuse angle. So to rewrite this, I would write if a triangle is an obtuse triangle, then it has exactly one obtuse angle. We can also write conditional statements from the Venn diagram. So inside again is our P or our hypothesis, and outside would be our Q. And so our conditional statement for this would be if an animal is a blue jay, then it is a bird. And that's how you would write a conditional statement from a sentence or a Venn diagram. Just a quick study tip. If you're looking in your book and you're looking for some problems to practice, as you're reading the section, look for these little check it out tags because they give you nice problems that correlate with your I can statements. Okay, so now let's talk about the truth value of a conditional statement. A conditional statement has a truth value of either true or false. If it's going to be false, there has to be a time when the hypothesis or the P part is true, but you can come up with a different part for the conclusion, or that the conclusion can be made false. So we're going to determine if these conditional statements are true or false, and if they're false, we have to come up with a counterexample which shows that the hypothesis is true, but the conclusion is false. So if this month is August, then the next month is September. So I'm thinking about this. Is there ever a time where the month is going to be August, but the next month is not going to be September? And there's never a time when that happens. So this conditional statement has a truth value of T, or true. Okay, for this next one, if two angles are acute, that is my hypothesis, then they are congruent. That's my conclusion. So I need to think about whether or not there is a time when two angles are going to be acute and they not be congruent, where the hypothesis is true and the conclusion is false. And I can think about a time when that would happen. So the truth value of this is going to be false, and here is my counterexample. So I need two angles that are acute, but that are not congruent, and that would be 10 degrees and 20 degrees. That's two acute angles that are not congruent, and that's why that has a truth value of false. Now, there are other kinds of conditional statements that you can write. Our very first kind of conditional statement we already talked about was an if P then Q, or P implies Q. The second type of conditional statement we can write is something called a converse. And the converse is made simply by exchanging the hypothesis and the conclusion. So it would be if Q then P. The second kind of conditional statement we can write would be the inverse, and an inverse is formed simply by negating the hypothesis and the conclusion. So the way that you would read this with that symbol would be not P implies not Q. And lastly, we have the contrapositive, which is a mixture of the converse and the inverse, and that reads not Q implies not P. So those are the other kinds of related conditional statements that you can write. So let's practice writing some of those. We're going to write the converse, the inverse, and the contrapositive of the conditional statement. This should say of the conditional statement. So prime numbers are odd. So how would I write that as an if then? If a number is prime, then it is odd. Okay, so I have to make sure that I can identify my hypothesis and my conclusion, because that's important for writing the other kinds of statements. So my hypothesis is a number is prime, and my conclusion is that the number is odd. So to write the converse, we have to do, this is Q implies P. So this is P and this is Q. So the converse would be if a number is odd, then it is prime. That's the converse of my conditional statement. The inverse is not P implies not Q. So the inverse would be if a number is not prime, then it is not odd. And then the last one is the contrapositive, which is not Q implies not P. And that would be if a number is not odd, then it is not prime. And that's how you would write the related conditional statements. I will tell you that for the most part, we're going to be dealing with the conditional statement and the converse of that conditional statement. But the others are important as well. All right, so make sure that you can do the following things. We'll practice more in class. I will see you then.